Hi, this video is called Triangle Similarity, and we're going to focus on what's called angle. So let's review at first what it means to be similar. So let's suppose now we're going to just talk about similar triangles. Okay, now remember we're talking about same shape but a different size. So what we have are congruent corresponding angles, and we also have not congruent sides but proportional corresponding sides. Okay, so let's kind of see what that might look like. So if we have this triangle similar to this triangle, similarity is kind of like copying something and pasting it and then enlarging or shrinking it. Actually, let's just be consistent with the orientation here just to make things a little bit easier. So here's a smaller version. And let's suppose that here we have A, B, and C, D, E, F. Okay, so if those are indeed similar, then two things must happen. These guys, the angles, corresponding angles have to be congruent. So B and E, A and D have to be congruent, and C and F. So let's mark that up. Okay, and also, because they are similar, we have to have the ratio of corresponding sides needs to be preserved. Corresponding sides are proportional, which means this: the ratio of AB over DE is going to be the same as the ratio of BC to EF, which is going to be the same as the ratio of AC to DF. Oops, DF, right? So we have AB to DC equals BC to EF, which is also equal to AC to DF, right? And that's what it means to be similar. Congruent angles, corresponding sides proportional. Okay, so how can we prove two triangles to be similar, or show, or know two triangles are similar? And for now, we're just going to give you one answer for that. And the answer for that is if they share two congruent pairs of angles. So we call that angle-angle relationship. Okay? So two pairs of corresponding congruent angles. That's what angle-angle means. Okay? So for example, if I looked at these two triangles here, let's say I had a 30, 60, 90, 30, 60, 90, and let's say I had a smaller 30, 60, 90. This angle right there is 30, that angle right there is 60. Then I could certainly establish that those two are similar. So to give it some letters, ABC, DEF. So triangle ABC would be similar to triangle DEF by angle-angle. They have at least two. And if they have two congruent pairs of angles, essentially by T180 and the no choice theorem, they have to have the third pair congruent. But 30, 30, that's one pair. And then let's use those 90s. So there's your two pairs of congruent angles. Therefore, they're similar. Now, once you know they're similar, that means the corresponding sides have to be proportional. So let's look at a problem that's going to use that idea. So that's going to look like this. And I'll give you an overlapping problem. Here's another example. And let's get this little action going on. And let's make those lines parallel. And we'll call that 4 and 2, and we'll call that X and 3 and Y, and we'll call that 6. Okay. Now, if I separate these two triangles, well, first of all, let's use those are corresponding angles. They're congruent, and these guys are corresponding angles, and they're congruent too. So, what I'm trying to establish is that the top triangle, which looks like this, that's 4, 6, and Y, is similar to the big triangle, the whole triangle, which looks like this. And here is your side of 6 for the whole triangle. Here is your whole side of Y plus 3 for that triangle. And then your base is X. Okay? So here are my congruent angles. So they're similar by angle-angle. Okay? Now, since they're similar, by angle. That means their corresponding sides have to be proportional. So I can go ahead and I can find the missing sides. And I'll do that now because I know they're similar by angle. They share 2, and if they share 2, they have to share 3 pairs of congruent angles. And I'm going to try to find the scale factor. So I'm going to use 2 sides for which I know the lengths, and so that's 4 to 6, which is the same thing as 2 to 3. And that's a scale factor that has to be preserved, right? So the ratio of small to big, corresponding side, is 2 to 3. Okay, so that means if I want to solve for this x right here, right, I use the ratio of 2 to 3 equals, so small to big, and the side that corresponds with this side of x is this side of 6. So 4 to 6 equals 6 to x. Okay, right, and then if I solve for x, 2x equals 18, which means x equals 9. Okay, so that side is 9. And we can check that. 4 to 6 is 2/3, equals 6 to 9. 6 to 9 is also 2/3. So we have corresponding sides proportional because of the angle similarity. Okay. Now let's see. I'm going to try to solve for y, and that's a little tricky here. Finding a color. There's y, and here's a y plus 3. So one way I can solve for y is by using the same scale factor. So 2 to 3 equals small to big y over y plus 3. Okay, so it looks like this. 2 to 3 or 4 to 6 or 6 to 9 equals y, this little piece, to y plus 3, the bigger piece. So if I solve that for y, I use the means extremely meaningless. 3 times y equals 2 times the quantity y plus 3, which is 2y plus 6. I subtract 2y from both sides, I get y equals 6. Okay, so that makes that 6, and that makes that 9ers. Okay, so now if I want to check to see if the corresponding sides are indeed proportional, and they should be because the triangles are similar by angle, 4 to 6, that's 2/3, equals 6 to 9, that's also 2/3, equals 6 to 9, that's also 2/3. Thanks for listening. Have a great day.